In this video, we are going to work on problem 3.2.4 from the textbook. Find the following limits. In the first problem, we have to find the limit as x approaches infinity of the cube root of x to the third plus 3x squared minus the square root of x squared plus 1. In the second problem, we have to find the limit of the same function as x approaches minus infinity. Now, let's focus on the first problem. Here, we see that when x approaches infinity, the first function here approaches infinity, and the second function also approaches infinity. Therefore, this is an indeterminate form. We will try to use some algebraic manipulation in order to calculate this limit. Observe that if we ignore the lower order term, then here we get cube root of x to the third, that is x. And similarly, if we ignore 1 here, we have square root of x squared, that is also x. But over here, this is cube root and this is the square root, and there is some difficulty when solving this problem. So our approach here is to separate this problem into two simpler subproblems that I'm going to explain in what follows. Now observe that the cube root of x to the third plus 3x squared minus the square root of x squared plus 1 can be written as follows. This is equal to the cube root of x to the third plus 3x squared minus x plus x minus the square root of x squared plus 1. So in order to compute the limit of the function under consideration, we are going to compute the limit of this function as x approaches infinity, and then we compute the limit of this function as x approaches infinity, and then we only need to add them together. So in the first subproblem, we are going to compute the limit as x approaches infinity of the cube root of x to the third plus 3x squared minus x. Okay, and now we are going to use the following formula: a to the third minus b to the third is equal to a minus b times a squared plus ab plus b squared. Okay, so imagine that here this is a minus b. So I'm going to multiply the top and the bottom by a squared plus ab plus b squared, so that the form a to the third plus b to the third will appear, and therefore we can eliminate the cube root over here. Okay, so this limit can be written as the limit as x approaches infinity of the cube root of x to the third plus 3x squared minus x. This is again a minus b. All right, and this is a squared, that is the cube root of x to the third plus 3x squared plus ab. So I'm going to write x first, x times the cube root of x to the third plus 3x squared. And this is b squared, that is x squared. Okay, and again we have to divide by the same thing. Now in the second step, as I mentioned, a minus b plus times a squared plus ab plus b squared is equal to a to the third plus b to the third. So over here we get this to the third, and therefore we can eliminate the cube root and get x to the third plus 3x squared minus b to the third here is x to the third. Okay, and then the bottom here we keep the same. Now here is a key step. We the top now is 3x squared, and at the bottom we factor out x to the third. So over here we get x to the third times 1 plus 3 over x. That is the part inside of the parentheses, and then we have to square the whole thing. Okay, and over here we do the same thing. We keep x the same, and we factor out x to the third to get x to the third times 1 plus 3 over x. And over here, x squared can be written as x squared times 1. Okay, so now this is x to the third square, so we get x to the sixth, and after taking the cube root, we get x squared over here. So now the bottom becomes x squared times the cube root of 1 plus 3 over x squared plus here the cube root of x to the third is x. So here we get x squared times the cube root of 1 plus 3 over x. And finally here this is x squared plus 1. Okay. Now what we're gonna do next is to factor out x squared. Right? At the bottom, x squared is the common factor, and inside of the parentheses you're gonna see that it is the cube root of 1 plus 3 over x squared plus the cube root of 1 plus 3 over x plus 1. And over here, we have 3x squared, and we already simplify x squared. And finally, now as x approaches infinity, the top here is 3, and the bottom here, this part approaches 1, this part approaches 1, and this part approaches 1 as well. So we get 3 over 3, that is 1. Okay, so we already finished solving the first subproblem. The second problem is much simpler. We are going to compute the limit as x approaches infinity of x minus the square root of x squared plus 1. Imagine that this is a minus b. So we are going to multiply the top and bottom by a plus b, so that the form a squared minus b squared will appear in this function, so that we can eliminate the square root. Okay, so the limit as x approaches infinity of x minus the square root of x squared plus 1 is equal to the limit as x approaches infinity of x minus the square root of x squared plus 1 times x plus the square root of x squared plus 1 over x plus the square root of x squared plus 1. Okay, over here on the top we get a minus b times a plus b, that is a squared minus b squared, and again we have eliminated the square root in the expression. So on the top we get x squared minus x squared plus 1. At the bottom we have x plus the square root of x squared plus 1. Okay, now here we can simplify the top and get minus 1, and at the bottom this is x plus the square root of x squared plus 1. As x approaches infinity, the first term here approaches infinity. And observe that the second term approaches infinity as well, and therefore the denominator approaches infinity, while at the top is a constant, therefore the limit here is 0. Okay? So finally, we only need to combine subproblem 1 and subproblem 2 in order to compute the limit of the function under consideration. And as you know, in the first subproblem, the limit is 1, and in the second problem, the limit is 0. Therefore, the limit of this function as x approaches infinity is equal to 1. Now we are going to focus on the second problem, in which we have to compute the limit as x approaches minus infinity of the cube root of x to the third plus 3x squared minus the square root of x squared plus 1. Before computing the limit, we have to determine whether the limit under consideration is of the indeterminate form or not. Okay. Now, as x approaches minus infinity, by ignoring the lower order term, over here we see that x to the third approaches minus infinity. Therefore, the cube root of x to the third plus 3x squared approaches minus infinity as well. And similarly, when x approaches minus infinity, x squared plus 1 approaches infinity. So here we get minus infinity minus infinity. So this is not an indeterminate form. We can write out right away this answer for this limit, that is minus infinity. Right? So we have finished solving problem 3.2.4 from the textbook.